Hello everybody. So today we're going to look at type checks and casts, and today's lesson we hope is going to be a little bit quicker. We I always remember that I am create I have I do create some slides here. I still have to update them. But yeah, you may want to look here if you want to have a recap of what we have done, and also if you want, we always have the you always have the possibility to look at my code in Kotlin with Luca repository. So that's that's pretty much what I want to say at the start of this video. If you like the videos and want to subscribe, you can do that, of course, and you can also turn on the notifications so that you get notified when I live stream again. So let's start with type checks and casts. So in Kotlin, you can perform type checks and to check the type of an object at runtime. So not at compile time, this means, but during the execution of your program. Type checks, typecasts enable you to convert objects to a different type. So to learn specifically about generic types, checks and casts, for example, list and map, see the generic type checks and cast. But this is part of something we will do later. Okay, so is and oh, I forgot the name of this in English. Sorry, guys. Punto exclamative? No. Exclamation point. Sorry, guys. Exclamation point and then is. This means something, and this is another operator, of course. So to perform a runtime check that identifies whether an object conforms to a given type, use the is operator or its negated form with the exclamation mark and then is. So this is actually the same as not. So if you see here, if it's not a string, then it will print not a string, and so on. So let's try this very quickly. Let's go on with the play with typecast function, and let's do val a is this is a string, and we will see that the type is going to be a string. And then let's do the two options that we have here. So if the object is a string, if a or s, maybe since it's a string, s is string, then print line the type of s is a string. Else, of course, it's not a string. Remove useless. Yeah, this instance check is always true, but that's what we're trying to do. Then if object is not a string, and then we could say let's create a number n figure with value 0, and if n is not a string, and you have to say it like this, then print line the type of n is not a string, and this condition n is not a string is always true. Incompatible types string and int. Right. I'm not sure why it is giving it in red. Should compile anyway. Yeah, so it's compiling. It's probably some issue with yeah, it just says incompatible type, but it's compiling, as you see here. All right. Then this is the same as let's do it again in another way. This is the same as this not, or if you also want, you can do the same version with the exclamation mark at the beginning. So like this. All right, let's go on. So smart casts. In most cases, you don't need to explicitly cast operators because the compiler automatically casts objects for you. This is called smart casting. The compiler tracks the type, checks, and explicitly casts for immutable values and inserts implicit safe casts automatically when necessary. So, for example, if you do what we have done here, so we check if s is a string, what we can do next is we can automatically use the properties of a string, for example, the length. We'll do it inside here. And as you see, as you may know, this might not be, the length might not be an object, property of an integer. So you would have an issue with that. In Java, what you would have done was, yes, checking the type, but also adding the s string here to cast it. And if you see here, it will say no cast is needed because the casting is performed automatically. So that's what a smart cast is. The compiler is even smart enough to know that a cast is safe if a negative check leads to a return. So if x is not a string, return, and then print x length. Okay. So let's try and do this. If n, what we can do, yeah, if n is not a string, then return, and otherwise print something. Print the length. Basically, if n is not a string, we would yeah, we could create a new n is not a string, maybe this, and return. Yeah, this would be better in a new function. Let's try this. So call returning smartcast. Let's create a function, and let's say if s, which is the argument which we're passing, is let's say it's any, and let's do this s and n. So I pass both s and n, and then we see the result. If s is not a string, then return. So we cut everything that we have in s. Otherwise, print line. Since s is a string, its length is s dot length, and we can see it. So let's do this. It's still complaining here. I don't know why. Anyway, should be good to go. Let's try it. So yeah, as you see here, we get it printed only once, because with the n, it will return and it will not do anything. So maybe you can say here string line, not a string, we don't do anything, right? So with the n, it's not a string, so we don't do anything. And with the s, since it's a string, we do something, okay? Control flow. So smartcasts work not only for the if condition, but also for the when expression. So that's great. What we could do is, yeah, let's say print len if string. Okay, better. Then what we can do is I don't know, print yeah, here it would be something different, like print next or length. Print next. Print, yeah, let's do print length if string, or number if int. Let's do like this. And we can say same thing as and then. Let's create the function. Not with n, but with any. And then now let's just a second, guys. All right. So yes, we're doing this function. So let's call this x. What we can do is we can say when x is of type integer, then print line something like x value. The value of this int is x. Otherwise, we can do string. If it's a string, the value of string, this string is x, and its length is this. Let's run this. All right, so we have the, yeah, it's not very readable, but what could we do here? We could do something like this. We escape the characters as we have seen, I think, in the last lesson. And we say the value of this string is this string, this is a string, and its length is 16. The value of this integer is 0. So based on the type, we're executing some function. This is called, yeah, this is some control flow type checking inside the when. If you declare a variable of Boolean type before using it in your if or when or while condition, then any information collected by the compiler about the variable will be accessible in the corresponding block for markcasting. Before using it in your if, when, or while, then any information collected by the compiler available at the about the variable will be accessible in the block for smart casting. Okay. So this can be useful when you want to do things like extract Boolean conditions into variables. Then you can give the variable a meaningful name, which will improve your code readability and make it possible to use the variable later in your code. Okay. So that this is something I do a lot in Kotlin actually. Maybe we can try the same example that they have here. Basically, the idea is that instead of doing what we have done here, we could say like private function allow printing if string, no? And then we say x any, and then we do it a little differently. We say when x, and then of course it will say add an else branch because it's needed. But here I want to return a boolean, so this will complain and it will say that we need to give an input value. If x is a new, now we say if x is string, then true. If x is integer, then false, and so on. Well, it would fall anyway in the false type checking. But now we can do, I know this is a little bit stupid, but what we could do is we can say instead of yeah, it's pretty similar to this, but if you have a lot of cases, it can be very useful. So what I would do here, which would end up in the same result as here, is if allow print if string, and then I pass the value of s, then I do the print line. And if I do this for n, it will not, of course, it will not run. So as you see here, it's running this code, which is the same as what we have copied here. Here it's a different example, but we can skip it. Logical operators. The compiler can perform markcasts on the right-hand side of the end or operators if there is a type check, regular or negative, on the left-hand side. So this is also quite interesting because we could like also check the sides, not only if it's a string or not. So yeah, sorry, in this case they're doing if it's not a string or the length is 0, then return, so do nothing. So if I pass a string, let's change this print length if string. We could do print length if string not null. So we get back to the previous function and we say if it's not a string or as length is 0. Then not a string, we don't do anything. Not a string or null string. So in this case, we are also checking if the length is greater than 0, basically. And if we do the printing, but we do it on some kind of string like empty string, it will return the same result as we had for integer types. Okay, we have an issue. Result reference print length is string. Print length if string. Oh, I haven't, not null. Yeah. I have renamed the function and it did not get renamed here. Where is the issue again? Also here. Sorry guys. Let's run again. Yeah. So not a string or null string, we don't do anything. So it is indeed a null string in this case. Next, so yeah, one more thing is that in this case, what we can see is that we're using markcast after this. So basically, if it's a string, then this check will be true. So it has to check this. But in this case, the compiler knows that it's a string, so we can use the property length, because as we said before, length is not a property of all objects, it's only a property of a string. Maybe, yeah, other objects like lists, but that's not the point. And in this case, also, if you use the end, you can do that. So what you could have done is you could have said if x is a string and x length is greater than 0, then do something else. Here it's a little bit pointless to do that check. What we might do is we might change it here just to show you another way of doing things here. So we delete this and we say if x is a string and x length is greater than 0, then we say allow print string, allow printing if string. So same thing if we do if we pass a null string, sorry, an empty string, then we will not get this line printed. So as you can see, we will have it only once. The type of s is a string with length s length, okay? And we get it printed only once. So next, if you combine type checks for objects with an operator or with an OR operator, a smart cast is made to their closest common subtype, supertype. So if you combine type checks for objects with an OR operator, a smart cast is made to their closest common subtype. Okay. So yeah, here it's doing type checking on multiple different interfaces, and so the type check will be on the supertype status. Okay, yeah, to their common supertype. So since there is a common supertype here, which is status, then the smartcast is going to be on super status. Maybe it's a little bit easier to show this one with some more code. Okay. So let's create as they've done here. Let's create this type of code like interface status. Let's do it here, interface status. Then we say function signal, and that's it. And then we say, okay, we can give the default type. Sorry, the default value, like would say the default body can be this is a signal. And what we can do now is we can create some other interfaces like OK, postponed, and so on. So we can say interface OK. We can say this is inheriting from status. Then we create another interface like OK, and then bad, maybe. And then we say, we do signal check, okay? So let's do run signal. Yeah, we can add another one like okay, then maybe, and then bad, and then no, okay? So in okay, maybe we print something, otherwise not. This is a signal from, okay, yeah, this is a signal, and then we could we could do this. Let's go down again over here, and let's do all. Yeah, we do create another function now. Sorry, private fun. Brings signal if okay or not, or maybe. So now we pass our object O, which is of type any, and then we say when we have O, and this is, let's do it how they're doing here. Yeah, if it is, we should do it like this. So when O is of type okay, or O is of type maybe. I like it like this because I think it's more readable. Then O dot, and then signal. Result reference. It's very strange. So it's not making the casting for some reason. Let's try and force it as signal. It was not signal. Status. So if I force it, it's working. Otherwise, no. Else do nothing. So that's pretty strange. We will try to solve this. Just let's try and see if it works now. So I'm passing. Okay. Okay, of course, this is not an interface. We have to create an object. To create an object, we have to do something like O. And then we have to say this is part of okay. Yeah, we cannot create the object from the interface, but let's see what happens. Yeah, it says O must be initialized. This should not be an interface. It should be a class or an object. So let's make them objects. Let's remove this and then let's say okay. And then it works. Okay, so I think there is not a mistake, but these should be objects and not interfaces, because we have status interface and object will be okay, maybe, and no, because they need to be initialized in order to be passed here and to be checked as objects. So there might be an issue here in the docs. So do nothing in this case. Otherwise, if we have okay or maybe, then print it. So let's do like this. Okay, maybe, and stop. And the last one is no. And now we should see two lines with the signal. This is a signal, this is a signal, and the third line will not be printed because it's not doing anything. But what we wanted to see was the smart cast. So here I'm doing it with a when. Let's try and do it with the if and see if the smart cast is working with the if. If O is okay, or O is maybe, then O dot signal It is with the signal. No, result reference. Or maybe it's an issue with the compiler. So that not with the compiler, but with the IDE. let's try and run it anyway. Yeah, there is an issue with the IDE because this should not be marked as unresolved. So in this case, it's a fleet that is not working well. We might check if it works in Android Studio. Let's try this. So just give me a second because I have to switch project. Kotlin with Luca. All right. So now that we are here in Android Studio, it's also complaining here. Interesting. So if I run it, it works. No, it's not working. So in this case, let's run it with that one. So in the if case, it's working. In the other case, with the when, it's not working. I want to do one last try with the or here. I don't think it will work, but dot signal. Let's see. Yeah, it's working. So with the or, you cannot use. Apparently, it's pretty strange because you cannot use the or with the operator. You have to use. Sorry, what am I doing? Yeah, you have to use the or with the two lines and not with the or operator. Apparently, probably this is some issue with the compiler anyway, but it's working, so we're happy about it. Next, so let's see inline functions. The compiler can smartcast variables captured within lambda functions that are passed to inline functions. So this is something a little bit different. Inline functions are treated as having an implicit calls in place contract. This means that any lambda function passed to an inline function are called in place. Since lambda functions are called in place, the compiler knows that a lambda function can't leak references to any variables contained within its function body. The compiler uses this knowledge along with other analysis to decide whether it's safe to smartcast any of the captured variables. So we have to look at this example first. Interface, we have processor with process as before, something similar to the signal. Inline function, we have an inline action. F, here we're passing a function with no parameters, which returns unit, so it returns nothing basically. And what this function inline function is doing is it's just executing f But what's the purpose of this? So we have next processor, which basically is going to be null in as when it's initialized, and then we have the function run processor. We what they do here is a variable processor. We initialize processor with null, and then we say if processor is not null, then processor dot process. Okay. So first of all, the processor must be not null. And if it's not null, then the process will be executed. And then it says processor equals next processor. So it will run this function that at this point will give null again. I don't really understand the purpose of this. This code seems a little bit useless. The compiler knows that processor is a local variable and inline action is an inline function. Okay. So references to processor can't be leaked. Therefore, it's safe to mark as processor. If processor isn't null, processor is a smartcast. Okay. So the compiler knows that processor is null, so no safe call is needed. All right. Probably what they want to say is just, yeah, in this case, since when processor is not null, it's safe to call dot process. I think this is what they want to do here. The thing is that they use these inline functions. The compiler can smartcast variables captured within lambda functions that are passed to inline functions. Inline functions are treated as having, yeah, this means that any lambda function passed to an inline function are called in place. Since lambda functions are called in place, the compilers know that a lambda function can leak references. Okay. Yeah, probably this has something to do with the inline functions, which basically what they do is that they do not create an object when you pass something to the function. Instead, they treat them as a function which run one after the other. So I have found before something about inline functions, when to use it. So let's transfer these, move tab to YouTube Live. All right, YouTube Live. Okay, so as you see here in this Stack Overflow answer, what they say is that let's say you create a high order function that takes a lambda. Okay, so this is my high order function, and this is the lambda that's taking the block. It executes like this, so before and after. In Java, this means that you are creating a function and you're passing a function, and you are invoking this function. After the before and before the after, basically. And when you call it from Kotlin, it is as we're doing here, so non-inlined, and then we're passing something. Okay. Yeah, under the hood, what it's making, it's wrapping the code inside a lambda, and So an instance of a function will be created. So you see this is an object actually. Okay. So basically calling this function and passing a lambda to it will always create an instance of function object. On the other hand, if you use the inline keyword, this does not happen. So in Java, it will be like this. So basically, if the inline modifier or operator will basically remove some overhead from so from Kotlin. So as you see here, however, they say that the docs give a reason why you wouldn't want to inline by default. It may cause the generated code to grow. However, if we do it in a reasonable way, avoiding inlining large functions, it will pay off with performance. So it's more performant in some cases and less performant in other cases. So basically, the code program might grow, so you don't want to inline by default. You must do it in a reasonable way. I think that it's worth keeping this because we'll see inline functions later, and moreover, I don't think this gives anything useful in the type cast checks and casts other than this check, which we've already done, like here. If n is string, then s dot length, and if we s nullable, we create an s nullable. We say if s is string, sorry, if s is not null, then we can do s dot length, sorry, s nullable. Let's try and print this as well. And then run it. So let's close Android Studio. Waiting for IntelliJ. Okay. So we get an issue. Nullable cannot be a value of non-null type string. Where are we? So sorry, I haven't put the question mark. Yeah, as you see here, it's yeah, in this case it's going to be null, so it's not executed. But if we now give it a value, this is a nullable string, then it should run. Yeah, nullable string. This is a nullable string 25. All right. Exception handling. So smart cast information is passed on to catch and finally blocks. This means your code safer. Yeah, this makes, your code safer as the compiler tracks whether your object has a nullable type. For example, so let's have, yeah, we're doing this. So we have a string input, which is set to null, and then we assign it to some string, okay? Then we try to print the length. At this point, the compilers know that string input is not null. The compiler rejects previous markcast information for the string input. Now, string input has the string question mark type. So we say it's null, and then we trigger an exception. If 2 is greater than 1, throw exception, and then assign string input to this again, and then the compiler, yeah, and then you catch the exception. So the exception is triggered. The compiler knows that string input can be null, so string input stays nullable. So the print line in this case will be null. So this will not be executed because we're throwing the exceptions, because 2 is always greater than 1, and then the catch will be executed. So it will execute this code, all this code, and then it will go inside the catch and print the length, but since there is no length, then it will print null. Okay. Unsafe. Yeah, we're almost done. So smartcast can be used in the following conditions. Val local variables always accept local delegate properties. Val properties if the property is private internal or if the check is performed in the same module where the property is declarated. Smartcast can be used on open properties. Okay. So, or properties that have custom getters. That's interesting. Variables, local properties. If the variable is not modified between the check and its user is not captured in a lambda, that modifies it and is not a delegate property. Variable properties never, because the variable can be modified at any time by other code. So basically, there are some limitations with the smartcast, and each time you use them, you should have some warnings from the compiler, so you should know when it's safe to use smartcasting or not. To explicitly cast an object to a non-nullable type, use the unsafe cast operator as. So, if you want to, what it's saying is that you have both an unsafe, and a safe casting operator. One is as, and one is as with the question mark. Okay, so this is safe and this is unsafe. You could do also string. Yeah, you could also use this type of casting, so as a nullable string. But I think it's better to use this type of syntax, like safe cast operator, and it should. This is because null country. To make the example work for possible null values, use a nullable type on the right-hand side of the cast. Not sure if this could. They don't say if this could give exceptions. I always use this type of syntax in my code, but maybe we can try it out. So what we can do is y as string, so as nullable as string. This should fail if it's null, so print line, try to print as nullable length, and then let's see. So now as nullable is actually a string, so it should print. What if we give null? Run. Yeah, IntelliJ is not does not know what it's doing. So yeah, null pointer exception. Null cannot be cast to non-null type Kotlin string. Okay, what would the Java programmer do in this case? They would do try, and they would do line, and then they would do catch, and then they would do exception, and then they would say, okay, code is not running, and then they would do something like this, and then they would run again and say, okay, my code is working now. I can do some more code after that. But yeah, you could say also null pointer exception here. Exception. But I mean, this is less readable than what I will show now. What you could do is you could say as nullable with the safe casting operator, and then this will basically return. Let's see what it does. It still returns a nullable string. So what I could do now is do let, and then print line, and do something like print this, and it would be better. Yeah, it still doesn't make a lot of sense because I'm getting a nullable here again, nullable string. So as you see, we don't get any exception because this code is not running since we are using the let, which basically checks if this is null, and if it's null, it won't be executed. Yeah, this operator, sorry, checks if it's null, and if it's not null, then it executes the code, otherwise it does not. But so if we say how and we run, then we don't have both the exception. We don't have both the exception, and we get these two lines printed. So always use the smart cast, the safe cast operator, sorry, if you have a nullable. Of course, if you don't have a nullable string like previously with the s, you can always use the as, and you won't run into any issue. In fact, if I print it here, it will never fail because s is not nullable. Yeah, as you see here, trying to print s will not generate any exception. And the compiler will complain if I assign null to s. Okay, so that's pretty much it for today. We have seen all how type checking and casts work. We still have to check how inline functions work, but this will be a topic for later episode. And so thank you guys a lot for watching. I will see you next time. And please, if you're interested in my content, subscribe, like the video, and I hope you stay healthy during the holidays, and let's get back next year with more programming. Bye, guys.